Hello learners, welcome again to another video lesson, and today I will teach you a new lesson which is the beginning of a new chapter in this subject. So from our previous lessons, from lesson 1 to lesson 9, you have learned about the random variables and its probability distributions. So in determining the probability distributions, we used samples of discrete data to find their probability distribution. However, remember that a random variable has two types. It's either discrete or continuous. So remember that not all data are discrete. We also have data which are continuous. Examples of these random variables which are continuous are your height, your weight, the age, and so on, the time, and so on. So the process in determining probability distributions of discrete is different from the process in determining the probability distribution of a continuous random variable. So in this lesson, we will consider a distribution of this type, commonly known as the normal probability distribution, or simply the normal curve. So at the end of this lesson, you're expected to illustrate the normal distribution, identify characteristics of a normal curve, and find percentage in a normal curve. So during your junior high school days, you have learned about the frequency distribution and how to graph this kind of distribution. So you also have learned that data can be spread out more on the left. So as what you can see on the picture, mas maraming data ang nasa kaliwa, or it can be more on the right, mas marami din yung nasa kanan. So tinatawag natin itong bias distribution kasi hindi pantay yung pagkaka-distribute ng mga data. So nasa isang side lang yung mas marami, or it's either on the left or on the right. Or meron din tayong data na naka-distribute in any direction. So it can be all jumbled up. But there are also cases that the distribution is normally distributed. So pantay siya, hindi siya bias sa kanan, hindi rin siya bias sa kaliwa. So pantay yung distribution niya sa kanan at sa kaliwa. And kung makikita natin, parang yung mga data natin is around a central value. So malapit siya sa ating central value. And we call this kind of distribution as normal distribution. We will learn more about normal probability distribution. This probability distribution is a probability distribution of continuous random variables. So again, we are done with the distributions of our discrete random variables. So this time, we will be dealing with continuous random variables. Remember that continuous random variables, the values can take between two numbers. So mas napag-aralan na natin yan. And this normal probability distribution is intended for continuous random variables. So it shows graphical representations of random variables obtained through measurement, such as the height and weight of the students. So examples of continuous natin is yung height at yung weight. It is sometimes called the bell curve. Why bell curve? So mapag-aaralan natin yan sa mga susunod na slide. It is used to describe the characteristics of populations and help us visualize the inferences we make about the population. So yung bell curve natin, yung normal probability distribution, is the best picture of how can we visualize or make inferences about our population, especially when we are dealing with random variables which are continuous. So mas madali nating maintindihan at maunawaan yung mga data natin when we are dealing with this kind of variables. It is also used to determine the probabilities and percentile of the continuous random variables in the distribution. So para mapadali yung pagkuha natin yung mga probabilities of continuous random variables and also the percentile, we use this kind of distribution. So ano yung itsura ng normal probability distribution natin? So if you have noticed, we have there the picture, the normal probability distribution. And if you have noticed, if you agree, it is bell-shaped. So parang yung hugis niya is yung hugis niya, kahugis niya yung bell. That's why it is also called bell curve. This is also called normal curve or bell curve. And it is also, we can compare it also to the shape of the chocolate hills in Bohol. So parang ano rin siya, chocolate hills. So this is the graphical representation. This is how we graph the data under the normal probability distribution. A lot of data follow this type of pattern, especially if our data are continuous random variables, are under continuous random variables. This is widely or commonly used in businesses, schools, and other fields that deal with the continuous random variables. Example, the height, the weight, the scores, the age, and so on. So example here is we have the distribution of height. So if you have noticed, the distribution of height are normally distributed because hindi siya biased sa kanan or hindi siya biased sa kaliwa. So pantay lang yung dami ng data sa kanan at sa kaliwa, and malapit sila sa center value or nasa gitnang value. They tend to be around a central value. So that's why this is called a normal probability distribution. What are the characteristics of a normal curve? Ano yung mga katangian ng ating normal curve? First, the distribution curve is bell-shaped. So kahugis niya yung campana or bell. Second is, the curve is symmetrical about its center. This means that if we draw a segment from the peak of the curve down to the horizontal axis, the segment divides the normal curve into two parts or areas. So if we draw a segment on the center of the curve, so just like what you see in the picture, so mula tuktok pababa sa horizontal line, so this is the horizontal line, the segment divides the normal curve into two equal parts. And take note, we have here the mu. The mu is located at the center of the curve. So again, this segment divides the curve into two equal parts. And kung ano makikita natin sa kanan, gayon din yung makikita natin sa kaliwa. So that is why the curve is symmetrical about its center. So parang katangian yung salamin. Parang salamin lang. So kung anong nakikita ng salamin, yun yung i-reflect niya. So again, it is symmetrical about its center. Next, the mean, median, and mode, which are the measures of central tendency, coincide at the center. This also means that in a normal distribution or a distribution described by a normal curve, the mean, median, and mode are equal. So you have learned this from your junior high school, that the mean, median, and mode are measures of central tendency. And they coincide, they are found at the center of the curve. So whatever the value of the mean is, it is also equal to the value of the median or the mode, or either way. Next, the width of the curve is determined by the standard deviation of distribution. So kung gaano man siya kalapad or kakipot, depende yan sa value ng ating standard deviation. So remember our standard deviation, it measures the distance, or it is the measure of dispersion, how the data are spread out. So if we have a standard deviation which is too narrow, ibig sabihin yung value ng standard deviation natin is small. If we have a curve that is too wide, ibig sabihin yung value ng standard deviation natin is large. Next, the tails of the curve are plotted in both directions and flatten out indefinitely along the horizontal axis. So ito yung tinatawag nating tails or buntot ng curve. So we have there the line, the curved line, which approaches the horizontal line indefinitely. So hindi natin alam kung hanggang saan yan. So these are the tails which approaches the horizontal line. So lalapit siya, lumalapit lang siya sa horizontal line, but it will never touch the horizontal line or the baseline. That's why the tails are asymptotic. Asymptotic meaning it will just approach the line but it will never touch it. So parang yung kasabihang pinagtagpo sila pero hindi tinadhana. Ayun. So that's why the tails of the curve are do not meet. So, hindi sila nag-intersect, hindi siya magta-touch sa ating baseline. So, ganun din sa right natin. So, if you're going to zoom in this picture, so makikita mong hindi lumalapat yung curve sa linya ng horizontal or sa horizontal line. And last characteristic is the total area under a normal curve is 1. So remember, when we are dealing with discrete, the sum of all the probabilities is 1. So the total area also in a normal curve, the total area under a normal curve is 1. This means that the normal curve represents the probability or the proportion or the percentage associated with specific sets of measurement values. So therefore, the total area here under the normal curve is 1 or 100%. So that represents the probability of the distribution, the total probability of the normal distribution. So again, the characteristics of the normal curve, just remember the 6 characteristics. First, it is bell-shaped. Second, the curve is symmetrical about its center. Third, the mean, median, and mode coincide at the center. Fourth, the width of the curve is determined by the standard deviation. Fifth, the tails are asymptotic to the baseline. And last, the total area under the normal curve is 1. And now, take note, the mean is found at the center of the curve. In statistics, specifically when dealing with normal probability distribution, we have the term empirical rule. So this empirical rule came from the observations of the statisticians. This is based on the experience or the observations of the statisticians when conducting series of experiments or gathering data. So this empirical rule tells you what percentage of your data falls within a certain number of standard deviations from the mean. This empirical rule is also called the 3 sigma rule. If you want to remember what empirical rule is, just remember the 3 numbers such as the 68, 95, 99.7, or known as the 3 sigma rule. So in this rule, first, 68% of the data falls within 1 standard deviation of the mean. So take note, under the normal curve, you have found there are scores under the normal curve. So you have there 0. To the right are positive values, which are 0, 1, 2, 3. And to the left, we have negative values, which are negative 1, negative 2, negative 3. So this 0 is equal to the mean. So this is our mu. This is already standard, the standard scores or the standard normal scores under the normal curve. So this 0 is equal to the mean, and if you have noticed, the distance from each score is 1. So this is already the standard deviation. So the distance from each score is 1. So this is the standard deviation. So again, in standard normal curve, the value of the mean is 0 and the standard deviation is 1. So going back to the 68%, so 68% of the data falls within 1 standard deviation of the mean. So we will, the mean is our baseline or the main starting point. So from 0 to 1, so it's 1 standard deviation. It's either to the right or to the left. So from 0 to 1 or 0 to negative 1, this comprises 68% of the data. So just follow the arrow. So from negative 1 to positive 1, which represents the 1 standard deviation of the mean. So this covers the 68% of the data. So meaning the data falls in this region, which are 68%. So 68% is more than half. More than half of the total data, which is 68%, falls here. Next, 95%. 95% of the data falls within 2 standard deviations of the mean. So again, from the mean, we shall count 2 standard deviations. So 1, 2. To the left, we shall count also 2 standard deviations. So 1, 2. So from negative 2 to positive 2, just follow the arrow. This area covers 95% of the data. So that is almost closer to 100%. So 95%, if you have noticed, mas malawak yung sakop niya kaysa sa 68%, because if you can see on the figure, mas malawak din yung region na sakop ng ating data, which is 95% of the data. Next is 99.7% of the data falls within 3 standard deviations of the mean. So from the mean, we shall count 3 standard deviations to the right or to the left. So 0, 1, 2, 3. Same with to the left. 0, negative 1, negative 2, and negative 3. So from negative 3 to positive 3, just follow the arrow. This region, so itong sakop niya, yung sakop niya is almost 99.7% of the data. This covers, so yung data natin, the data falls within this region. So that is almost 99.7% of the data falls within 3 standard deviations of the mean. So this is almost 100%. So konti lang yung hindi niya nasasakop. So this is 99.7% of the data. Our distribution from the percentage, if this is 0, and if this is 1, so from 0 to 1, the percentage that is covered, the region that is covered is 34%. So this is 34% of the data. Same with from 0 to negative 1, this is also 34%. So again, because the characteristic of the normal curve is symmetrical, so what you see on the right is also what happens to the right also happens to the left. So if this is 34%, this is also 34%. If we add these two values, it will be equal to 68%. That is why from negative 1 to positive 1, it covers 68% of the data. Next, from 1 to 2, standard score. So it covers from here, going here from 1 to positive 2, so it covers 13.5%. From 2 to 3, it covers 2.35%. And from 3 onwards, on the remaining region, it's 0.15%. So it goes the same way. It goes the same thing with to the right, to the left of the mean. This is negative 2 and this is negative 3. So if we add these values or this percentage, if we're going to add all these percentages, it will be equal to 100%. 100% or 1. This already represents the probability of our normal random variable, or normal distribution. And this part, half of this part is equal to 50%, which is to the right of the mean, and also to the left of the mean covers 50%. And this is also 50%. So that's it. These are the percentages under the normal curve. So let's have example number 1, drawing a normal distribution. The height of senior high school students is normal distributed with a mean of 150 centimeters and a standard deviation of 10 centimeters. Sketch a normal curve that describes this distribution. So after knowing the situation or the problem, we have to identify our important terms here, important given. So we have here the distribution is normally distributed, and we have a random variable that is continuous, which is the height. The mean is 150 centimeters and the standard deviation is 10 centimeters. So we are going to sketch a normal curve that describes this distribution. So we're going to, step 1, we're going to sketch a normal curve. So to sketch a normal curve, just remember the bell, since our curve is bell-shaped, or simply the hills, the chocolate hills of Bohol. So you're going to draw the normal curve. Next, we're going to identify the mean. Where can we put, or where are we going to place the mean? So since the mean is found on the middle of the curve, So it goes on the middle. Now take note that in our standard deviation, or in our normal curve, or in our normal distribution, the mean is equal to 0 and the standard deviation is equal to 1. So from the mean to the standard deviation is equal to 1. So we have here 1, 2, 3. So this is to the right of the mean. The values are positive. And take note the distance from each value, or from each score, is 1 standard deviation. And to the left of the mean, the values are negative. So we have here -1, but still the standard deviation is 1. So these are the standard scores under the normal curve. So we have the 0 as the mean and 1 is as the standard deviation. So since this is our mean, 150, the next step is we're going to place each score or each value of height with a standard deviation of 10 centimeters. Ibig sabihin, the distance, each standard deviation is a distance of 10 centimeters. So from the mean, the distance from each height is equally 10 centimeters away from the mean. So first, from the mean to the right of the mean, so it's to the left, we were going to subtract 10 centimeters. So 150 minus 10, it's equal to 140. So from 140, we're going to subtract 10. So it's equal to 130. And from 130, we're going to subtract 10. So it's 120. So notice that the distance from each value is 10 centimeters. And from the mean to the left, going to the left, the values are decreasing. So we can also say that this is below the mean. So the values below the mean are decreasing. Next, we're going to the right of the mean. So from 150 to the right of the mean, or above the mean, we're going to add 10 centimeters. So that is 160. And from 160, we're going to add another 10. And from 170, we're going to add 10. So notice that the distance is 10 centimeters, which is the standard deviation. And if you have noticed, the values to the right of the mean are going up or higher. And we can also say that the values to the right of the mean are increasing. So this is how we illustrate the normal distribution with a mean of 150 centimeters and a standard deviation of 10 centimeters. So I hope you get the process. So next, we have example number 2, finding percentages in a normal distribution. So we still have the same situation. The height of senior high school students is normally distributed with a mean of 150 centimeters and a standard deviation of 10 centimeters. So this time, we're going to get the percentage. So approximately what percent of these students have a height greater than 170 centimeters. So we are interested on the percentage, how much of the students, or what percent of the students have a height greater than 170 centimeters. So meron silang gaano kaya karami, or what percent of the students have a height greater than 170. Ibig sabihin, meron silang height na 171 pataas. So since the height is greater than 170. So first, we're going to sketch a normal curve or a normal distribution with a mean of 150 centimeters and a standard deviation of 10 centimeters. So I know you already know this. So we're going to sketch a normal curve with a mean of 150 centimeters and standard deviation of 10 centimeters. So we have 6 standard deviation, 6 scores, 6 scores, or 6 standard deviations. So from the mean, we have 3 standard deviations, and to the left, 3 standard deviations. So after drawing or sketching the normal distribution with the mean and standard deviation, the next step is we're going to find where can we find the 170 centimeters. So it is located here. So this is our 170 centimeters since we are interested with the height greater than 170. So this is our starting point. So since this is the 170 centimeters, so the height is 2 standard deviations above the mean. So if ito yung ating mean, 150 centimeters, so ilang standard deviations ito malayo sa mean or away from the mean? So it is 1, 2. So if you have still remember, under the normal curve, the mean is 0 and the standard deviation is 1. So from the mean, so 170 centimeters, 170 centimeters is 2 standard deviations away from the mean. So this is our standard deviation. Next, we're going to shade above the 170 centimeters. Why? Because we're interested with height greater than 170. So, saan ba natin makikita yung mga values or yung mga height na mataas kaysa sa 170? Sa kanan ba? Or sa kaliwa? Sa kanan, pakanan, or pakaliwa? So, of course, the values that are greater than 170 is found here, to the right of 170 or above 170. So, dito natin makikita yung mga values such as 171, 172, 173, 74, 75, 180, and so on. Since these are greater than 170. So, dito hindi natin pwedeng i-shade dito kasi the values here, the values to the left of 170 are lower than 170. So, dito lang tayo interested. So, next, what shall we do after shading the region where we are interested in? So, we are going to add the percentage in that shaded region. So, you already know that if this is the mean, 0, and the standard deviation is 1. So, from 2 to 3, the percentage that is covered is 2.35% of the data. And from 3 onwards, this covers 0.15% of the data. Since this part is the shaded region, so dito natin makahanap dito yung mga values na greater than 170. In this region falls the data which are greater, or the height which are greater than 170. So we're going to add these percentages. In doing so, we have 2.35% plus 0.15%, that is equal to 2.50 or 2.5%. So if you have noticed, the shaded region is too small. So maliit lang yung portion na sakop niya from our normal curve. So that is why the percentage is also small, which is 2.5%. So konti lang yung mga estudyante na may height which is greater than 170 centimeters. So to answer the question, about 2.5% of the students have a height greater than 170 centimeters. So we have example number 3, finding the whole count. So still we have the same situation where the mean is 150 centimeters and the standard deviation is 10 centimeters. But this time, we have a given number of students. So there are 500 students in the distribution. So approximately, how many of these students have a height lower than 140 centimeters? Ilan kaya sa 500 na students, ilan kaya ang may height, ang may taas na lower than 140 or mababa sa 140 centimeters? So, ibig sabihin yung values, yung height nila may values na 139 centimeters. So, the first step is we're going to draw the normal distribution with a mean of 150 centimeters and a standard deviation of 10 centimeters. So, alam nyo na to. So, we have there the normal curve with the normal distribution with the mean. Nasa gitna yung mean natin, which is 150 centimeters. So, next, we're going to locate where is our 140 centimeters. So, since we are interested in knowing how many students have a height lower than 140 centimeters, so hahanapin muna natin saan ba from our normal distribution, saan natin makikita yung 140 centimeters? Okay, so ito siya, klarong-klaro. So, andito ang ating 140 centimeters. And if you have noticed, it is located to the left of the mean or below the mean. So, if this is our mean, which is sa ating normal curve, the value of the mean is 0 and the standard deviation is 1. So, from 0, the standard deviations or the distance from each value is 1. So, we have here 1 standard deviation and another 1 standard deviation, which is and another standard deviation. So, if the values are to the right, if our standard deviations from the mean are to the right, if the values are to the right of the mean, the values are positive. And if the values are to the left of the mean, so the values, the standard scores here, or the z-scores, are negative. So, negative just indicate the direction if it is to the right or to the left. If it is negative, then it is found to the left of the mean. So, makikita natin na andito yung ating score na yung height na 140 centimeters, and it is 1 standard deviation away from the mean, which is negative 1. So since the height 140 centimeters is below the mean, which is 1 standard away from the mean, so we're going to shade the region where we can find the heights lower than 140 centimeters. So, saan ba tayo interested? So, saan ba tayo interested? Saan bang banda tayo interested? Saan ba makikita yung mga height na lower than 140 centimeters? Sa kanan ba or sa kaliwa? So, of course, we're interested since the heights are lower than 140, so we are going below the mean to the left of 140. So, dito natin makikita ang mga heights na lower than 140, such as 139, 138, and pababa hanggang sa 120. So, dito natin makikita. Bakit hindi pwede dito? Kasi yung mga values natin na nandito are already higher or greater than 140. So, hindi pwede na dito tayo mag-shade. So, dito tayo sa kaliwa kasi dito natin makikita yung mga values na lower or mababa sa 140 centimeters since we are interested on the students with a height lower than 140 centimeters. And from our previous discussions, we already identified that if this is our mean, which is 0, this is negative 1 standard deviation, and this is 2, negative 2, and this is negative 3. So, from negative 1 to negative 2, or this is, yes, from negative 1 to negative 2, the percentage na sakop ng region na yan, from here to here, is 13.5%. And from negative 2 to negative 3, here, ang sakop niya, ang region niya comprises 2.35% of the data, and from negative 3 onwards hanggang dito, so it comprises 15% of the data. So, what are we going to do with this shaded region? Anong gagawin natin sa mga percentage na nasasakop ng shaded region? Or not? Yes. So, we're going to add the percentages in the shaded region, because shaded region means ito ang sakop na mga dito natin makikita yung mga values na lower than 140 centimeters. So, we're going to add the percentages in the shaded region. So, by doing so, we have 0.15% plus 2.35% plus 13.5%, which is equal to 16%. You can check that by using your calculators. So, therefore, the students who have height lower than 140 centimeters is about 16%. So, sa 500 students natin, 16% doon, merong height na mababa sa 139%. Now, where we are interested, ilan kaya sa mga estudyante, since 16% of the students have height lower than 140, so ilan kaya sila? So, how do we do this? We simply multiply 16% by 500. So, we will get 16% of 500. So, by doing that, just multiply. So, just apply your knowledge in getting percentage of whole numbers. So, 16% of 500 is simply 16 hundredths times 500. So, 0.16 times 500, that is equal to 80. So, ibig sabihin, merong 80, merong kabuuang 80 estudyante, 80 students na may height na 140 centimeters. So, about 80 students have a height lower than 140 centimeters. So, again, this is very useful in determining the number of students in a certain distribution.